So here we are on TryHackMe's Pre-Security Network Fundamentals Intro to LAN. We're just going to go one thing at a time because these are kind of a little bit long. Some of them are short, but some of them are long. It says 15 minutes, but this is going to be a lot longer than that. Anyway, so let's start off with introducing LAN topologies. So local area network or LAN topologies. Over the years, there has been experimentation and implementation of various network designs. In reference to networking, when we refer to the term topology, we are actually referring to the design or look of the network at hand, all right? So let's discuss the advantages and disadvantages of these topologies below. So basically, however the network is set up, right? That's what topology is. So we've got star topology. That's this one right here. The main premise of star topology is that devices are individually connected via a central networking device, such as a switch or a hub. This topology is the most commonly found today because of its reliability and scalability, despite the cost, right? So it costs the most, but it's the most reliable and it's the most scalable, and those are two important things, all right? Any information sent to a device in this topology is sent via the central device to which it connects, all right? So we can see we've got 8 computers here, and they're all sending their info to this, what do they call it? Hub, a switch, whatever. And then it'll route it to wherever it needs to go, all right? Let's explore some, what? Any information sent to a device in this topology is sent via a central device to which it connects. Yeah, that's what we said. Let's explore some of these advantages and disadvantages of this typology below. Topology, my bad. Because more cabling and the purchase of a dedicated networking equipment is required for this topology, it is more expensive than any of the other topologies, all right? Yeah, because like each one of these is going to have a cable that runs to the thing. We're going to actually have to have a dedicated thing. And there we go. Like this one here, it's just cables. This one here, it's just cables. And those are the only two other than this one we see. However, despite the added cost, this does provide some significant advantages, right? So for example, this topology is much more scalable in nature, which means that it is very easy to add more devices as the demand for the network increases. Yeah, so we just add another 8, 1, 2, 3, 4, 5, 6, 7, 8, no big deal, and it would still do what it does as long as the thing supports 16 computers, all right? Let's see. Unfortunately, is that good? Yeah. So unfortunately, the more the network scales, the more maintenance is required to keep the network functional. I mean, but that goes for anything. Like a little toy boat is going to take a lot less maintenance than an aircraft carrier. I mean, that's just life, right? So this increased dependence on maintenance can also make troubleshooting faults much harder. Yeah, well, there's going to be more things to troubleshoot, but whatever. Furthermore, the star topology is still prone to failure, albeit reduced. Yeah, everything's prone to failure, so don't even worry about that. For example, if the centralized hardware that connects the device fails, these devices will no longer be able to send or receive data. Thankfully, these centralized hardware devices are often robust. Yeah, so basically the only way to really stop this thing is to bust this thing up right here. And if everything goes down, and we don't really have to troubleshoot too much. We know where the problem is, so we just get our spare in the warehouse and we just bring it over here and boom, fixed. So yeah, let's go to the next one. So we got bus topology. So this type of connection relies on a single connection, which is known as a backbone cable. This type of topology is similar to the leaf off of a tree in the sense that devices or leaves stem from where the branches are on the cable. You know what? Honestly, I thought it was like a bus because you're on a bus and you either choose this side, you sit on this side of the bus or this side of the bus. I don't know, but I guess if you want to call it a leaf, whatever. Because all data destined for each device travels along the same cable, it is very quickly prone to becoming slow and bottlenecked if devices within the topology are simultaneously requesting data. Yeah, so if this one's requesting a bunch of data in this one, and this one, and this one, and this one, yeah, this thing's going to get bogged down real quick. This bottleneck also results in very difficult troubleshooting because it quickly becomes difficult to identify which device is experiencing issues with data all traveling along the same route, right? I'll take your word for it. I mean, it makes sense, I guess, because I mean, this one would instantly know which one was the bad one. And this one, we'd have to like go through like, okay, is it this one? Is it this one? Is it this one? And whatnot, right? Lastly, another disadvantage of the bus topology, is that there is little redundancy in place in case of failures. Goodness, let me read that again. So lastly, another disadvantage of the bus topology is that there is little redundancy in place in case of failures. Okay, whatever. This disadvantage is because there is a single point of failure along the backbone cable. I guess so. Like if this messes up here, the rest of them will stop, I guess. All right. So if the cable were to break, devices can no longer receive or transmit data along the bus. All right. Makes sense. All right, let's go to the next one. Ring topology. So the ring topology, also known as token topology, boasts some similarities to, I guess, bus, devices such as computers are connected directly to each other to form a loop. So they're talking about this one right here. Meaning that there is little cabling required and less dependence on dedicated hardware such as within a star topology. True. I mean, we just need this cable, this cable, this cable, and this cable. So that's 4. I mean, I guess this one we need 1. And if, let's say there's only 4 computers, we need 1, and then we need some sort of splitter, and then another cable splitter, another cable splitter, another. But I bet this one is the cheapest of all. But you know, we can't do that for like hundreds of computers, right? So let's go. So a ring topology works by sending data across the loop until it reaches the destined device, okay? Using other devices along the loop to forward the data. Interestingly, a device will only send received data from another device in this topology if it does not have any to send itself, right? So basically, let's finish it up first. If the device happens to have data to send, it will send its own data before sending data from another device, all right? So if this one's sending data and this one just sent it data, this one, and like if this is sending like 5 gigabytes and this is just sending like 5 megabytes, right? It'll send the 5 gigabytes first and then the 5 megabytes. And then this one will have to wait for the 5 gigabytes. This one will have to wait for the 5 gigabytes. Well, actually, no, it'll get to here. Or, you know, you get what I'm saying. So even if it's like a tiny little bit, it's not going to say, oh, you can go to the front line. No, that's not how it works. All right, so let's go to the next thing. No, let's go to this. So lastly, ring topologies are less prone to bottlenecks, such as within a bus topology. Yeah, because, I mean, I guess that makes sense. As large amounts of traffic are not traveling across the network at any one time. Okay. The design of this topology does, however, mean that a fault such as a cut cable or broken device will result in the entire network breaking. So true. So yeah, if this is cut up, I mean, who's going to be cutting cables? But I guess we are on cybersecurity, so it's something we might have to watch out for. Cut cables, or if the device itself is off or broken, I guess that's going to be a problem. Well, let's go to the next one. So what is a switch? So switches are dedicated devices within a network that are designed to aggregate multiple other devices such as computers, printers, and other networking capable device using Ethernet. Or any other networking capable device using Ethernet. So these various devices plug into a switch's port. Switches are usually found in larger networks such as businesses, schools, or similar sized networks where there are many devices to connect to the network. Okay. Switches can connect a large number of devices by having ports of 4, 8, 16, 24, 32, and 64 for devices to plug into. So yeah, like we saw up here, we got 8, but we could add 8 more and get 16, and maybe 16 more and get 32 and whatnot, right? So switches are much more efficient than their lesser counterpart, hubs or repeaters, which we're not really going to talk about. Switches keep track of what device is connected to which port. Makes sense. I mean, it would have to, right? Because anyway. So this way, when they receive a packet, instead of repeating that packet like to every port, like a hub would do, it just sends it to the intended target, thus reducing network traffic. So yeah, so this would be like, internet, go find me what the weather is, and it'll say, okay, weather from computer 6 on switch 1 needs some internet. All right, so it knows 6 on switch 1 needs some weather. Switch 1 computer 6 needs weather, blah blah blah, and then it comes back here, give it to 6. All right, something like that. All right, so both switches and routers can be connected to one another. The ability to do this increases the redundancy or the reliability of a network by adding multiple paths for data to take. I'll take your word for it. I mean, how is it going to be multiple paths though? If one path goes down, another can be used. While this may reduce the overall performance of a network because the packets have to take longer to travel, there is no downtime, which is a small price to pay considering the alternative. I don't get it. I guess this is just a bad example for what they're talking about. So I really don't know how that would work, but whatever. We'll figure it out later. So what's a router? It's a router's job to connect networks and pass data between them. It does this by using routing, hence the name router. True. Routing is the label given to the process of traveling. Routing is the label given to the process of data traveling across networks. Routing involves creating a path between networks so that this data can be successfully delivered. Okay. So routing is useful when devices are connected by many paths, such as in the example diagram below. Why would this happen though? Why would you have 4 routers before hitting another computer? Honestly, I don't get it, but I guess this is just a really simple thing that doesn't really maybe there's more computers over here and switches over here. I don't know. Anyway, so here's the practical. Attached to this task is an interactive practical featuring the discussed LAN topologies. We're going to learn about the various ways in which they are vulnerable to breaking. We're going to break the LAN topologies to retrieve the flag. All right. So they're talking about this thing up here, this view site, but we're going to do that after answering these questions. All right. Because we want to get down to this one before we start doing that. Whatever. Anyway. So what does LAN stand for? We know that. Local area network. Let's do it. Local, that's not how you spell anything. Local area network. Boom. Submit it. Beauty-mas. What is the verb given to the job routers perform? I bet it's routing. Routing. Let's see it. Submit it. Beautiful. All right. So what device is used to centrally connect multiple devices on the local network and transmit data to the correct location? A switch, right? SWITCH. Submit it. Very true. What topology is cost efficient to set up? The bus topology, right? Let's do bus topology. Submit it. I knew it because it had 3 letters. And what topology is expensive to set up and maintain? Star topology. Star topology. How about that? Submit it. Looks great. Now let's do complete the interactive lab for this. So let's go up here. I got a scroll wheel on my mouse now. I got a new mouse. View site. And then let's do it. So topology flaws, pardon me. So this lab is going to take us through the flaws in different network topologies. Let's go to the next one. So here's the ring topology right here. In a ring topology, all devices are a connector to 2. What? Pardon me. Let's say that again. In ring topology, all devices are a connector to 2 others to create a full circle. Okay. So this one's connected to this one and this one. Yeah. So 2. And it makes a full circle going round and round. Next. Oh, look at that. It's a circle going round and round. Circle of circles. All right, so packets of data travel from one device to the next until they have reached their destination. I believe it. All right, so one of the major flaws with a ring topology, is that if a device goes down or a cable is broken, then data will no longer be passed. Okay, if we hover over the middle of the network cable, we can cut it and see what happens to the packets. Let's do it. Snip. Uh-oh, big trouble. Remember, we're doing cybersecurity, so this is a serious situation right now. We got to figure this out. All right, so the packets can now no longer travel around the network, and no devices can talk to each other. But at the same time, if this is a local area network, what's that got to do with the internet? I don't know. Let's go. All right, so here's the bus topology, the bus of leaves. Okay. With a bus topology, all devices are connected to a single cable, often called the backbone. The backbone, the leaves with the backbone on the bus. Can you pick a motif? All right, let's go. Data is sent in both left and right directions. So this one just went that way, and this one goes that way. Okay. And down the backbone until the packet's destination is reached. All right, so here's the black one's going that way. The black one, it reached this one, it was fine. This one's sent in purples. It didn't like that one. It didn't like that one. Oh, that one was fine. Okay, we saw it. Bus topology, A major flaw in the bus topology is that it can't handle a large amount of data. Believe it. On the next step, we're going to send as many packets as quickly as we can to try to take down the network. All right. So let's send it from computer 1 to computer 5. Let's send the packet. All right. There it is right there. Going. Now let's send it again. Let's send it. Let's just send us so many. So many. We broke it. Next. Oh, if it isn't star topology, So with a star topology, all devices are connected with their own cable to a central switch or hub, right? Every packet is sent through the switch, which means if the switch goes down, the network will no longer work. Makes sense. See if we can somehow break the switch. How are we going to break it? Oh yeah, with a hammer. What kind of hackers are we? Here you go. How are we going to get into this network? Oh yeah, here, I got my hammer. Boom. This network is now down. We won. Okay. THM topology flaws. Looks like that's what we're getting. Let's scroll down here and type it in here. THM topology _ flaws. That's how you spell it. Let's submit it. All right. It doesn't care what the what is the thing called? It doesn't care about a case, what case we're in. All right. So this was an 18-minute video, and it's like literally said, let's get this. I finally figured out this is how we can exit split view. I finally figured out that we can do show split view here. We can hit that button to go get out of the split view. But anyway, as you can see here, it says 15 minutes, but this was a 18-minute video to start with, right? So whatever. Anyway, so now we're on to a primer on subnetting, and we'll see you next time.